on the event. Let's start with what we know. A black hole is born from the death of a massive star. When a star at least 20 times the mass of our sun runs out of fuel, it can no longer support its own weight. Its core collapses under its immense gravity, squeezing all that matter into an infinitesimally small point. This point is called a singularity. Imagine crushing the entire Earth down to the size of a marble. Now imagine crushing something much, much bigger into a space with zero volume. That's a singularity. The gravity here is so powerful that nothing, not even light, can escape its pull. The boundary around this singularity is what we call the event horizon. It's not a physical surface you can touch. It's the point of no return. Once you cross it, you're locked in. Think of it like being in a river that's flowing faster than you can swim. No matter how hard you try, the current will always carry you downstream. For a black hole, that downstream direction is always towards the center, towards the singularity. So, what would happen if you actually fell into one? Well, it depends on the size of the black hole. If you fell into a smaller, stellar mass black hole, the tidal forces would be extreme. The gravity at your feet would be so much stronger than the gravity at your head that you'd be stretched out like spaghetti. This rather gruesome process is actually called spaghettification. It's not a pleasant thought, but it's what the physics tells us. You'd be torn apart atom by atom before you even reach the singularity. But what about a supermassive black hole, like the one at the center of our Milky Way galaxy, Sagittarius A? These giants are millions or even billions of times the mass of our sun. Because they are so large, their event horizons are much farther out from the singularity. The tidal forces at the event horizon are much gentler. In this case, you could actually cross the event horizon completely intact, without even noticing. You'd be doomed, of course, but for a little while, you could be alive and well inside a black hole. And this is where things get really weird. According to Einstein's theory of general relativity, once you're inside the event horizon, space and time do a little switcheroo. Outside the black hole, you can move freely in any direction in space, up, down, left, right, but you are always moving forward in time. Inside the black hole, this is flipped. You can no longer move freely in space. The singularity isn't a place in space anymore. It's a moment in time, in your future. You are pulled towards it just as unstoppably as you are pulled towards tomorrow. Every possible path you could take, every direction you could try to move, leads to the singularity. It's an inevitable future event. So what is this singularity? General relativity describes it as a point of infinite density and zero volume, where the laws of physics as we know them completely break down. Our best theories, including Einstein's, can't describe what happens there. It's like trying to divide by zero. The math just gives you nonsense. This is a huge sign to physicists that our understanding is incomplete. We need a new theory, a theory of quantum gravity, to merge the world of the very big, gravity and space-time, with the world of the very small, quantum mechanics. And this is where we leave solid science behind and enter the realm of mind-bending speculation. What could a theory of quantum gravity tell us about the singularity? One idea is that the singularity isn't an infinitely dense point at all. Instead, it might be something called a Planck star. In this scenario, as matter gets crushed down, quantum pressure pushes back, preventing it from collapsing to an infinite point. Instead, it forms an incredibly dense, compact object. The matter would then bounce and start expanding again. But where would it expand to? Here's a wild thought. What if the singularity is a gateway to another universe? This is part of the fecund universes, or black hole cosmology theory. The idea is that when a black hole forms in our universe, the matter that collapses into the singularity bounces and creates a brand new baby universe with its own Big Bang. In this picture, our own universe might have been born from a black hole in some other parent universe. It's an incredible cycle of cosmic birth and death, with black holes as the seeds of new creation. Another mind-boggling idea comes from something called the holographic principle. This concept suggests that all the information about what falls into a black hole isn't destroyed at the singularity. Instead, it gets encoded on the two-dimensional surface of the event horizon, like a hologram. From the outside, it looks like everything that falls in is just stuck on the surface, scrambled up. If this is true, it might mean that our entire three-dimensional universe could be a holographic projection of information stored on a distant two-dimensional surface. Yes, you heard that right. We could be living in a giant hologram. Then there's the information paradox. A fundamental rule of quantum mechanics is that information can never be truly destroyed. But if something falls into a black hole and hits the singularity, where the laws of physics break down, what happens to the information that made it up? For years, Stephen Hawking argued that the information was lost forever. This created a huge conflict between general relativity and quantum mechanics. Later in his life, Hawking changed his mind. He proposed that information isn't lost, but is stored in a weird, scrambled way at the event horizon, and then slowly leaks back out over trillions of years as the black hole evaporates through a process called Hawking radiation. This radiation is a faint glow of particles that every black hole emits. Over an unimaginably long time, a black hole will radiate away all of its mass and disappear in a final flash of light. The information about everything it ever swallowed would be returned to the universe, though in a completely jumbled and unrecognizable form. So, to recap, falling into a black hole could mean being spaghettified, or it could mean a smooth ride across the event horizon. Inside, you might find a singularity of infinite density where physics breaks, or you might find a Planck star bouncing to create a new universe. The black hole might be a hologram storing information on its surface, or it could be a wormhole, a theoretical tunnel through space-time connecting distant parts of our universe, or even connecting our universe to another one entirely. The truth is, we just don't know for sure. The inside of a black hole remains one of the greatest unsolved mysteries in science. It's a place where our most trusted theories fail, forcing us to search for a deeper understanding of reality itself. It's a laboratory for the most extreme physics imaginable, pushing the boundaries of human knowledge and imagination. What do you think is inside a black hole? A gateway to another dimension? The birthplace of a new universe? Or just a point of pure chaos? Let me know your wildest theories down in the comments. The universe is a strange and wonderful place, and the quest to understand its secrets is what makes science so exciting. Thanks so much for joining me on this journey to the heart of darkness. If you enjoyed this cosmic exploration, don't forget to hit that like button and subscribe for more deep dives into the mysteries of our universe. See you next time.